almost a completely open slate of 10 weeks to fill. So if you have ideas, they don't have to be specific people, but if you have topics that you like to see covered, we'd definitely like to hear that. Or if you have specific people, including yourself, let either one of us know. I want to remind everyone again that we are live on the web and archived on the web, and when you do ask questions, you need to hold down the touch button so the red light is lit as you're speaking, and when you're done, you can lift off and our speaker will answer the question. And so therefore, I will now announce or introduce our speaker. We have David Hampsten, who is one of our MURP candidates, finishing up his degree. And this is the presentation today is the result of his field area paper on bicycle level of service in Northwest Portland. Without further ado, I'll hand it over to you.
Great. Thank you very much, Jennifer. Anyway, the presentation, as you know, is on bicycle planning more or less in Northwest Portland, but it's not planning per se. It's much more of sort of a GIS and statistical analysis of various data. Purpose of the presentation is multiple. It's mostly to describe the research that I've been doing. And this research has actually been going on for about 5 years now. To describe a lot of the methods that I used. I'll be concentrating mostly on methods as well as on the various data that I used, as well as some of the other data that's available for bicycle GIS analysis, especially public data. I'll also be relating some of the results, but not as much detail as I would in the paper. And I'd like to receive a lot of feedback from you on the research, if I may. Give you a little bit of background on this project and on myself. As many of you know, I'm an avid cyclist. I don't drive. I don't actually own a car. And in fact, I never learned to drive. And so bicycling is kind of important to my daily activities. Before I worked at PDOT for a while, I was a bicycle advocate for a lot of projects around town, especially Interstate Max, generally acting as a private consultant. And I was using GIS, or trying to use GIS, those geographic information systems, to promote bicycle advocacy, sort of as a tool of propaganda, if you like. Then for 2.5 years, I was a GIS technician, engineering trainee, if you want to be technical about it, at the City of Portland's Office of Transportation. And at that time, picked up additional skills and tools for doing my analysis. And then finally, in this process, I wanted to develop a method to model bicycle level of service, or service provision levels. And so that's pretty much what the focus of the field area paper is on. It's bringing all these different components together. I have to explain what a bicycle level of service is. The actual description from the United States Highway Research Board, and this is from 1965, is a qualitative measure describing operational conditions within a traffic stream and the perception by motorists and or passengers. Basically, for all intents and purposes, for most cities, to improve bicycle level of service, it means putting in off-street paths that is safer bike routes that are much better for recreational cyclists. And generally that means an off-street path or a bicycle boulevard that is a street where all the signs, stop signs, are in favor of the cyclist, and generally they put in various restrictions for car traffic on the street. But for a lot of other cities that are trying to encourage commuting, it generally involves putting in painted bike lanes. And generally they go on busier streets and on arterials and that sort of thing. And for many cities, they have to play a game of balancing the costs and the benefits of the various improvements they put in. For most cities, these improvements tend to be piggybacked on other projects, usually a road project that has money for other provisions. The federal governments and various state governments encourage or even require various communities to put in bicycle facilities. So when I put together the project, my scope of the project was to examine various available bike data, to correlate various bike and traffic data with each other, and to find significant variables for any future GIS work. Basically, I wanted to find out what variables were important for further analysis and what variables were pretty much irrelevant. Question? Oh, sorry. Anyway, the project site is in northwest Portland. It's an area that a lot of you are probably familiar with. I included pretty much all of downtown. I also included the area across the river in Albina. And then I, just for geographic variation, topographical variation, included Washington Park, which is a very hilly area. Kings Hill over here. Or no, not Kings Hill, it's Kings Heights, excuse me. And then Nob Hill area, the uptown area, and the industrial northwest area. Okay.
Yes, why did you select Northwest Portland for your study?
I wanted somewhere that was, because I mean a lot of my field research had to be done by myself. And so I wanted somewhere fairly convenient. And at the time, I lived in northwest Portland. I figure it's also a very diverse neighborhood. It's geographically diverse. It's also the different kinds of people living in the neighborhood. There's a mixture of industrial, commercial, and residential land uses. A lot of single-family homes in certain areas, and a lot of multifamily apartments in other areas. And also, I wanted to include the river. And also, a lot of the data that I had was concentrated in that area. Unfortunately, the data is not universally available for all areas. I'm going to spend the next couple of minutes looking at the data. I looked at a whole bunch of variables, and I had to actually create two indexes from the variables, one of which I called a safety index. It was created from the Metro Bike There map, which has come out at least 3 different times. I used the 1999 version. The map basically rates better or worse routes based upon city designations. And usually, for instance, a street that's officially designated as a bike boulevard or a bike lane tends to be rated better. A lot of other streets, heavy arterials that are used, were rated worse, relatively. And basically freeways were not rated at all, since bicycles are not allowed on them within the city of Portland. And this is not universal in all cities, but within Portland this was the case. And then I created an index based upon these. So I had a whole bunch of relative ratings, and I needed to create a ranked index. And so essentially I had an ordinal ranking of various types of routes. And then I had to convert those ordinal rankings into a format that my GIS program could recognize. And I was using ArcView, which has does some very strange things with data, which I'll get into a little bit later. I also created another index looking at speed. For me, the safety index was pretty much aimed towards recreational riders, basically recreational riders aimed towards areas that have a higher safety rating, and commuters generally looking for areas where they can go faster, with safety being a less important factor. And that was based upon a lot of literature that I found on commuting behavior. So I created from the same data source a speed index, but I used a model from Edmonton, Alberta, which basically took a look at various kinds of streets and found that people riding on sidewalks generally went a lot slower because you have a lot of joggers, pedestrians, and that sort of thing. And they basically found that people went between 6 and 8 miles per hour on a recreational path, whereas on a city street they'd go oftentimes around 10 or 12 miles per hour. Then on major arterials that had a bike lane, they would often go about 15 miles per hour. And even higher numbers were recorded for freeway shoulders. As I said, in Portland, that's not a common thing, but I know in the Bay Area, a lot of people use expressways for cycling. And there, the speeds are typically around 20 miles an hour. Again, I used the Metro Bike There map for data. And the index was adjusted from miles per hour to a ratio that ArcView could understand. And then I broke down the rest of the variables that I looked at, and I looked at quite a few, into nominal, ordinal, and ratio type data. Nominal data is basically named data, sort of Boolean operations for those of you who are familiar with GIS type work. Basically, it's either is something or it isn't something. So in the case of land use, it's either commercial or it's not commercial. And so I had to break down the data for that. So I would basically take a look at a land use map, find the areas that are predominantly commercial, and then record that. For me, a commercial area includes retail, restaurant, office, industrial, fairly straightforward. Residential, I lumped all the apartments and single-family homes together. I think had I done this again, I would have separated the two. I included for parks, fields, a lot of open areas, basically recreation areas, trails, that sort of thing. And then I had a separate variable for the river. And I was aiming towards the proximity to the river within a, say, 3-block proximity to the river. Just because for the river was essentially an impedance variable. There's only so many crossings at the river, and so I wanted to account for that. Then I also looked at the presence or absence of bike lanes, and essentially that would be a nominal piece of data. And then the presence or absence of railroad crossings, which can be rather dangerous for cyclists. Anyway, give you an idea of the local land uses. There's quite a variation, as you can see. But generally, the north areas to the northwest area, I should say, is heavily industrialized, as is Albina, and then the east side industrial area here, near east side, excuse me. And then the downtown is predominantly commercial, and then uptown's a mixture of commercial and high density, and Pearl District is a mixture of industrial and high density residential. And then you can see the hills here are predominantly single family residential. That's why I probably should go back and reclassify that area. And then Washington Park is one of the bigger parks, and that did have an impact on the analysis. And as you can see, I had the river right down the middle, and that had, again, a big impact. The ordinal data, as I mentioned earlier, the safety index that I created was an ordinal ranking of safer or better streets. Parking density could be calculated, but for the sake of simplicity, I created it as an ordinal sort of more dense parking, less dense parking in certain areas. I show this photo here to give you an idea that the parked cars can actually be at least a perceived hazard to a lot of cyclists. And I did actually have a lot of literature saying that that is, for many cyclists, a significant issue. Roadway slope, there was some topographical variation in all of this, not just on the West Hills, but even over in the Albina area. There's some steepness. And it was relative steepness on certain sections of road. I'm not looking for actual or absolute height changes. And then pavement quality. Basically, for cycling, you're looking at the rightmost 5 feet of the travel lane on a regular street. And then on a bike lane, theoretically, they're 5 feet wide. In fact, they vary everything from 3 feet to 5. And then on a lot of streets, I was essentially looking at the gutter. Oops. How do I go back? Oh, there.
I use the up arrow.
Up arrow? Okay. All right, thank you. Then I looked at a whole bunch of ratio data. The speed index is essentially a ratio. Ratio meaning you can break it up into smaller bits, divide it by other numbers. Basically numbered data that isn't ranked. So I got to street width, for instance, when I was doing my job at PDOT. We were doing street feature mapping, streets, sidewalks, that sort of thing. And so I was able to get the actual street widths from curb to curb. The automobile average daily traffic, that is what's typically known as ADT. These are traffic counts that are done sometimes a couple of times in the year. Sometimes it's every other year for a lot of streets. But basically it's how many cars actually go on that street. Usually on a Tuesday, I think, is the typical day. And you see the counting boxes around town for that sort of thing. Most of the counts came from the city, but for the larger highways, I used ODOT figures. And then I got from Jeff Smith over at PDOT the bicycle average daily traffic counts. They have actual counts for the bridges for most years. And then there's a class, I think a biology stats class, that every summer they send out students to actually count at other points. They do it from between 4 and 6 p.m. on a weekday, and then they multiply that by 5 to get the average daily traffic for that day for those intersections. And that set of data was really actually quite helpful for the later analysis. Then I ran 3 models, essentially. Each model being a modification of the previous one. As I realized that there were errors in each previous model, I'd run a new model. And so the first model, or the main data structure I had, it's 259 points. It was in a geographically stratified distribution. I'll show you in a map in a minute of the points. Data input was through ArcView GIS software. And I used a base map for the Metro Regional Land Information System, which is what a lot of us here at PSU use for any of our GIS work. A lot of the additional data was collected by yours truly. I had to go out and actually count or make an estimate of various items. The data was recorded for statistical analysis. That means I had to recompile it in such a way that ArcView could actually understand the data. ArcView won't recognize zeros. So anything that's 0 on a value, I have to put its 0.001. And ArcView has other similar problems with the data. Plus, I wanted to make sure that all the variables were equivalent within the data matrix, and so that one was not favored over the other during the analysis. And then I'll give you an example of some of missing ratio data that I needed to interpolate, and I used the GIS to do that. It was especially with the bike ADT that was important. Anyway, gives you an idea of the distribution of the data points. So I wanted to make sure that they covered the whole geographical area, including the river, the freeways, the hills, and all that. And then later I realized that in doing that, trying to make it geographically even, I've made some major errors as far as statistical modeling. And I'll get into that in just a minute. Yes?
So why were you tracking on the freeways as well? I mean, if we're looking at
Well, because they physically occupy space. And I think when I originally put the model together, I was kind of thinking, well, what if cyclists use the freeways like they do in other places? I mean, granted, cycling in this freeway is somewhat dangerous, but it's really no more dangerous than a lot of other places. And you can go a lot faster.
Do you know, is it illegal in Oregon?
It is illegal on freeways, or that is interstate freeways within the city of Portland. There's one freeway in Eugene that it's illegal on, but the other freeways it's legal. And then it's legal on all other interstates within the state of Oregon. Oregon's unusual. Other states ban them altogether, ban cyclists. But in California, they have these roads known as expressways, which are essentially freeways but paid for locally. And they encourage cyclists. They even have signs up for cyclists. Even though it's pretty dangerous, you can go much faster in an expressway. And so that actually helps commuting cyclists quite a bit. And I've seen a whole bunch of other studies saying something to the effect, if you just allow cyclists on these roads, you might actually get reasonable numbers of travelers. But yeah, it's Highway 26 you're allowed on until the tunnels, essentially. You have to get off at the Cillian interchange.
Yeah.
But
What do you do?
well, then you take Canyon Road, but it's not that bad. But I don't know. It's that was kind of an important issue, and I later realized, as far as the freeways, that I needed to be under the freeways. I didn't want to be on top. The rivers, I don't know. That was a tricky issue. I was trying to. It was a case of trying to create a spatially interesting GIS, and then realizing that bicycles cannot physically ride on water. At least not enough of us are Christ. But anyway, I used the arc view to interpolate data points. There were a whole bunch of data points where I didn't have bike ADT data. It's hard to see on here, but there's a bunch of black dots. Those are points where I actually had bike ADT data. And the color here indicates where the concentrations were of bike ADT. This is relative concentrations, but it's basically I took the highest figure and divided all other figures into it. So this point of 1, which is on the Hawthorne Bridge, obviously has the most bicycle traffic. Anybody who's ever ridden on the Hawthorne Bridge can pretty much see that. And then again, you get very high concentrations of cyclists on all the bridges. The problem is I didn't have so many data points out here in the suburbs of the study. I mean, of the suburban portion of the study, I should say. And so I needed to figure out what the actual bike ADT was likely to be. So I used the GIS to interpolate that data. And then from this map, I was able to figure out what the new data was likely to be. And then I projected the information into all the data points in the study. Okay.
You might have mentioned it before, but what were those adjusted ADT, those classifications based on information?
Oh, okay. Well, what it is I have bike traffic figures for a whole bunch of points. And they vary everything from about 50 cyclists a day for some of the areas in the West Hills to, I think, 2,860 cyclists per day on the Hawthorne Bridge. Well, the way ArcView operates is, in order to make the regression, make each of the numbers within the regression tables equivalent, I needed to take the highest number and all the other numbers and divide it by the highest number, so that the highest number would get a 1, and that the lowest numbers would get like 0.005, I think was the lowest, so that everything is within a range of 0 to 1. It's just the way ArcView operates. So I'm sorry I put that table in there, but it's this is what the model looked like rather than the original table. but they are equivalent. I mean, I didn't lose anything in the process. Anyway, I ran it. Okay, go ahead.
I have a small question regarding the slide before this. You placed a point for the value that you are assigning, but for the Hawthorne you had 1 point, right?
For which point?
For the Hawthorne Bridge.
Right,
you had
right.
Just 1 point.
It's just 1 point. I should have, looking back on it, put a distribution of points across the bridge.
Exactly.
But
if you are interpolating the surface,
right.
you need a bunch of points, I think. What do you think?
Right. Yeah, you're right. Basically, the software I was using was something called Spatial Analyst, and it would take that point to the next point, which might have like a figure of 900 for another count, because there are a bunch of counts just off the bridge. And basically, it would interpolate the numbers in between that 900 and 2,000 something. So it's pretty much the same thing with car traffic. Yeah, I was basing it upon particular points, and that can kind of screw up the GIS a little bit. And I should have put in a series of points. But on the other hand, then you have too many points. I mean, basically, you get to the state where you have too much data. And so I was trying to limit the number of points I had. I wanted to make sure I had enough to do a regression. 259 is plenty. But, I could have put in 500 and would have gotten something spatially more accurate. But as far as GIS, as far as statistical analysis is concerned, this is actually enough points. Or at least talking with my advisors and also for my own work, I figured it would be enough. But you're right. I mean, as far as a spatial distribution, I would agree with you totally. Anyway, then I ran several regressions on the data. I had compiled by no means an exhaustive list of variables, but enough to run some regressions and get some preliminary results. I ran basically on each model 3 regressions, one looking at speed, and then another looking at safety, and then later a third looking at bike ADT. Basically, I wanted to find out what variables were influencing the indexes, or what variables might influence the indexes, I think would be a little bit more accurate. Since the indexes were created from using the Metro Bike Theory map and having to make various value judgments on that, and then I had a whole bunch of data that was collected independently of that, I wanted to find out what variables influenced decisions that went into putting in bike lanes and that sort of thing that the Bike Theory map recorded. And then since I had actual bicycle counts, I wanted to find out what might be influencing bicycle behavior or high traffic use in those areas, given the variables I had. Now, keep in mind, there are other variables that I could have collected, like tree coverage and accident data and that sort of thing, which might have been interesting as well and might have been important on the regression. So Model 1 covered the whole area, the 259 points, and I realized pretty early on including data points for river water was not a great idea, and that the freeways were screwing everything up because the freeways have car traffic counts that are astronomically higher than area streets or surrounding streets. Most city streets have traffic counts of between 1,000 and 5,000 vehicles per day, and some of the freeways have between 80,000 and 150,000 vehicles per day. And since bicycles aren't allowed in the freeways, I realized pretty quickly that it was pretty erroneous. The R-squared values, by the way, were pretty high, but I pretty quickly realized that they were not very useful. The underpasses, by the way, were not really accounted for, and so what I did for the freeways was just reassign the points so that they had the traffic that's below the freeway accounted for. So I ran a second model that used fewer points. I'll show you the map in a minute. It covers roughly the same area, but the freeways were changed to the underpasses, and so their car ADT numbers were much, much lower. Only the Willamette Bridge crossings were used to cross the river. I didn't use any of the river specifically. And so there were 219 data points, which is still enough to run lots of regressions. It had a lower R-squared value, that is the square of the regression, which means that there were likely to be more errors in the regression. But I'd say the relationships were probably a lot more meaningful since the model itself is much more logical. Basically, the results showed that there was higher bike use near the river. There was higher bike use on bike lanes. I mean, some of this stuff is pretty self-explanatory, like no duh. But surprisingly, there was more bike use along industrial areas. And, you know, there is a certain logic to that in that after 5 p.m. there's basically no traffic in an industrial area. But in many cases, it was just commuters having to go through an industrial area to get somewhere else. And then there generally was lower bike use near residential areas. Again, it was basically a lot of commuters going to and from somewhere and just passing through certain areas. And not surprisingly, there was less bike use on steeper slopes. What I found interesting is the other variables were not statistically significant that I looked at. Railroad crossings, a lot of the other land uses. They just apparently didn't have much bearing on bicycle traffic. Anyway, I realized, Model 2 was pretty much all these white points. They're on gray. The bike ADT data was collected from these, what you might call the bullseyes here. And I wanted to run a model that concentrated more on the bike ADT data. I had a greater concentration of data in this area. And so I basically removed all these points from the third model, which effectively got rid of a lot of topographical variation. But I just wanted to see whether I got any differences in a sort of flatter terrain in a third model. And basically, as I said, there was a greater dependence upon actual collected bike ADT data. There were fewer estimates using interpolation methods within a GIS. It was a slightly smaller, flatter area. There were 160 data points. The influence in parks and slope was reduced just because of the West Hills being effectively eliminated from the study. The significance of car traffic actually increased, which did actually surprise me a little bit. And the relationship with the other variables remained the same as in Model 2. The ones that were significant were still significant in roughly the same levels, but the other variables that were not significant continued not to be significant. And so I did an analysis of the model, or the various models. I basically came to the conclusion that at least in Northwest Portland, cyclists there are predominantly commuters, just judging from the fact that they generally follow heavily trafficked streets, that is, streets with a lot of congestion. Cyclists prefer busy but well-paved streets. Cyclists seem to prefer to travel in industrial areas or along the river and away from residential areas, at least within this particular area. Cyclists love painted bike lanes. The bike lanes usually had a very high regression value. Cyclists appear to be indifferent to all other land uses, railroad crossing slope, and parking density. However, I did find a few problems with the models that I, in a later date, I'll probably go back and try to redo. It would be nice if somebody else collected the data and then a different person actually compiled and did the regression on the data. I think it's kind of important that the collection of the data and the compilation of the data should be somewhat separated. I'm worried that I personally might have put some bias within the system. I think that's a reasonable worry. More data variables need to be collected. There were a lot of variables that I didn't even look at, such as tree coverage. I tried to get accident data, but that was a real problem. And there were other variables. And then there's the problem with simultaneity of variables, something that Jim Strathman goes on and on about. This is especially important with bike lanes. Bike lanes were the presence and absence of a bike lane was a variable. But bike lanes also influenced the speed and safety indexes. Obviously, when the bike theory map was set up, streets that had bike lanes were given better ratings, and those without were not. So obviously, there was a relationship between that. And then on top of that, bike lanes, at least within the city of Portland, and I actually checked with Bellevue as well, and they do the same thing, are only put on busy arterials. They're generally not put on collectors or other residential streets. And they're usually put in only in new projects where they're repaving a street. So, and the putting in the bike lanes is highly influenced by the actual traffic counts on a street. And so generally a street with a high traffic count is going to have a bike lane. And so, yes, they should actually correlate with each other very highly. And they did. And so for future research, I'd want to, as I said, separate the data collection from analysis. I'd also like to do a project study over a regional area. Part of the problem with the study was such a limited area that obviously a lot of cyclists are just simply passing through to somewhere else, going to work in the industrial areas or going to work in the uptown or downtown areas. And so it'd be probably smarter to do it over a larger area. It'd be interesting in that context to compare bicycle connectivity and travel behavior, especially with the bike ADT data, to compare those. Be even more interesting is to model nighttime bicycle facility provision. That is, street lighting, bicyclist perceptions of hazards in the way, bad pavements, garbage, that sort of thing. I was talking with a few others of using more sophisticated statistical techniques to look at some of this bike data, to use nested models and various other methods. And I'm still trying to get a hold of bike accident data. And ODOT apparently has, what little they have is not terribly useful. This is at least according to Tom Jensen over at PDOT, who uses some of their stuff, and PDOT doesn't have much better data. I'm trying to get a hold of somebody at OHSU. Apparently the EMT people actually record that kind of data and apparently do a more thorough job. And that's it, folks. Questions? All right, let's start with Jerry, the hard one.
Can you talk a little bit about the algorithm that ArcView uses to estimate your data points? Now, I guess I have a couple thoughts about it.
Okay, go ahead.
One is, it sounds like it's a smoothing algorithm, that it's basically designed to kind of maybe describe the shape of a surface,
Right.
where you have maybe elevation estimates at different points. So
Right. It's definitely interpolates those points, and it is essentially, as you say, a smoothing mechanism. It's basically trying to create a topographical shape or description of your. I mean, essentially, I was using these data points as elevation points. It's creating a topographical map of those data points, and then I was having to go to a certain intersection where I'm collecting the data and extract that elevation point based upon that interpolation. And it's especially important for the bike ADT data, but less so in some of the other.
I mean, did you inform the GIS that anything that had a building on it had a .001 traffic count?
Yeah, I actually did go back and recompile, especially for the river, for instance. or for certain areas in Washington Park where there were no trails even, let alone a road, I would put into the data, I'd recompile those points as 0.001 for bike ADT data. Now, those same places did have slope, obviously, and some of the other things. I later realized that those non-areas were more or less irrelevant on some of the later models, but I wanted to see what they looked like on the original models.
But they're also useful for non-river
Correct.
points, because if I'm at one point and I'm trying to get to another point that's 10 blocks east and 10
I see
blocks
what you mean.
north, I cannot go in a straight line.
Okay, what I
And
did...
so everything that has a building on
Right.
it ought to have a .001 traffic count. So that's one thought that I had about this. The other is
Right.
that you could also probably test the success of your smoothing model through, I forget the exact technique the exact name for it, but it's basically I think it's called out of sample estimation. So in other words, take out a data point, run your smoothing model to see what it thinks the traffic count is at that point, and then see how successful it is.
I did actually do a little bit of that. As far as your first point, this study was looking at the facilities that are on the ground for cycling, and I wasn't terribly concerned about connectivity or travel. So I was looking at how good is that intersection or that section of street for a cyclist. I was not so concerned about how connective it was to another point, if you see what I mean. That would be a totally different study, and I tried to stay away from that. I had to actually limit the study. So I know what you mean. For instance, you've got a whole railroad yard in between 2 points. You can't technically cross through there. But I really didn't care about that. What I cared about was how good is the road at that point. And it wasn't just that point. It's sort of an area around the point, about a block in all directions. So yeah, connectivity was not really one of the things I was even looking at on this study. But thank you. You had your hand up earlier. Okay.
David, when you were looking at variables, did you consider a time factor such as time of year? Or something?
I thought about that. Even time of day would have been interesting. When I was doing parking counts, I did actually do it 2 different times of the day. And again, times of the year. Nice thing about Portland is we don't really have to worry about snow for any more than 2 or 3 days of the year. Had I done this in Minneapolis, that would have obviously been a vital issue. But as far as rain, I mean that would be another factor, is to look at slickness from rain and that sort of thing versus the dry, super ultra arid dry weather we have in the summertime, to compare those two, to do a seasonal variation. And then, of course, if I was doing a nighttime thing, night here is much longer in the wintertime than in the summertime. And again, that would be an important factor. I did think about those, but no, I didn't really collect anything on that. Okay.
Is there statistical research being done like this in the agencies responsible for bicycle facilities?
Well, as I said, some of the information I got directly from PDOTs. They have a whole section that does some bicycle research. It's what's the section called? Oh, transportation options. Thank you. They do some bicycle research, and as I said, I got it from Jeff Smith from that section. I know Metro also does a lot of bicycle research. That said, yeah, I got a lot of literature from various publications on what other people are doing in other cities and other regions on bicycle facility provision, and it's actually quite useful in many cases. There's actually quite detailed studies in Iowa and Hawaii, of all places. Apparently they have statewide databases on accidents that actually have a lot of importance on how other people are doing research. So yeah, there is actually a lot going on, especially in larger cities or cities where bicycling is more important, especially college communities, Eugene, Davis, Boulder. Go on.
Are bike counts in any way automated? And then, if they're not, and given how costly labor is, why would you try to collect data in that way? Why not travel diaries?
Well,
Why not survey people where there are bike stops and collect data? I mean, especially considering how few people actually do bike.
Well, I'll tell you that for most communities, and I was looking chiefly at cities in the Pacific Northwest and also in BC. They have to have, the individual cities have to have certain bicycle counts to account for the money that they're using for bike projects. They must use money for bike projects because the federal government and state governments, to a certain extent, require them to do so. And it's even stronger up in BC, where the provincial government there basically says you have to. That said, cities like Portland only have limited money to do any sort of counts, whether it's regular street traffic counts or bike counts. I was talking with Tom Jensen, who's pretty much in charge of the PDOT traffic counts, and he does both the bike and the traffic. And it showed me what the counting devices are, but basically they can only do a couple of points per year, and to get the additional counts, as I said, was pretty much from a class where the professor contacted Jeff Smith and had the students go out and collect the data, essentially for free. I mean, there's no other way it could have been done. Now, as far as using travel diaries and that sort of thing, yeah, that would be ideal, but and I believe it's done on a limited basis, but the problem is you have to have the personnel to do it. It costs a certain amount of time and thus money. But the way these students are collecting that data, they go out to points where there's probably already some bicycle traffic. I mean, it's not done purely by random. And so for some of the other points where I needed certain data, like out in the suburbs, I had to physically go out there and collect it myself just so I had some sort of distribution of points. And there were not points where there was a lot of bike traffic. Good.
I think that one of the other concerns about travel diaries is that it's been shown that people forget about the shorter trips that they make, and bicycle trips are often shorter trips. So
right, yeah,
that might be
that would be another
about
important factor. Or if they drive as well as bicycle, the bicycle thing was just recreational, whereas the car trip was, significant travel behavior.
Just to follow up on that, I mean, I'm not talking about trying to do a general population
right, I understand, but
bicycle diary.
But to aim it specifically at cyclists, yeah, I understand perfectly. But even among cyclists, there's a lot of car drivers. Let me go for RF here, and then for you.
Yeah, you mentioned your ADT was based on like peak hour, 4 to 6 p.m.
Right.
So I would suggest that you're only counting for utilitarian or commuter cycles.
Oh, I see what you mean, during those times. Well, what they did on the bridge counts is they found that 21% of all the traffic, for the bridge counts, they did a whole day, usually a couple of days. And they found that 21% of all the traffic occurred between 4 and 6 p.m. So that's why they took that number for when they had the students go out, they would collect only between 4 and 6 p.m., then multiply their numbers by 5 to get the total daily counts, just because it was based upon these bridge counts. You see what I mean?
But it seems like you would be missing the recreational cyclists.
No. The bridge at least would capture the recreational cyclists as well as the commuters. You're right. A lot of the recreational riders don't even cross the bridge. You're right. And there is that error, and there's also the error, even on the bridge counts, that a cyclist passing through the city takes a while physically to go from 205 to the West Hills. I mean, it just takes a lot longer than it does for a car, and there's also that error. But they did try to capture that as well. I mean, it's not totally captured, but then you have the same errors with car ADT as well. because there is some interpolation going on in there, because you're only capturing it for a couple of days. The weather might be nice, it might be nasty. So it's just the best we have, but you're right. You're right. Rob.
Look, we have a question coming in by email.
Okay.
I always like to say that. The question is there a report or thesis, a document available? And I have a question too,
okay.
So I'll let you answer both. But in connection with the data collection issue, there's a national, probably international realization that data relating to non-SOV travel is pretty limited, and I know a lot of people are interested in, let's say, as a technology person, new technology, and maybe as a cyclist and a bicycle researcher, do you have any thoughts on systems we could either develop or test for improving the way we collect bicycle data, as an example?
Well, it's been suggested to put units on bicyclists that would record where they go. Personally, I think that it's a little bit, you might have a weight problem, but with microelectronics, it's probably not such a big deal. But B, I think most cyclists would be horrified by the whole concept. Sounds vaguely like Big Brother. As far as the study, right. I mean, I've seen such devices. It's as far as the study, yeah, it's part of a thesis. It's a portion thereof. It's not quite finished. It depends on a particular faculty member getting approval from them. And the main problem I'm having is just collecting some accident data or finding out whether such information exists. But yes, when I finish this, and if anybody would like a copy of it, I can send them an electronic copy of it. I figure it'll be finished by December, or failing that, early next year. And I'd be happy to send, if they want to give me their card or leave a note on a pad here of their email, their name, their affiliation, I'd be happy to send them a copy, probably in either in Word format or as an Adobe document. All right, so let me go for you first, and then.
Are you aware of any data on bicycle trip length and how that is or is not correlated to a certain level of service?
I have actually seen a study on bicycle trip length. I think it was from Toronto. And there was, and I've seen various other studies about travel behavior and length. Basically, that cyclists tend to go anywhere from a mile to about 7 miles on a typical trip. I've even seen a study of, given a certain means of transport, you're likely to go this distance. So pedestrian, for instance, is anywhere up to 3 miles, typically closer to 1.25 miles. And so, yeah, I've seen studies on that. As far as actual raw data that you can get a hold of, I believe I've seen a couple of studies on that, I mean, where people actually collected data. But for most cities, I mean, it's just like, I would love to have that kind of data, but we'd actually have to pay for it. You know, have people go out and collect it, or as Jerry was saying, travel diaries or something to that effect. I had a question over here, and then I'll go over here.
The title of your paper is Bike Level of Service, which
right.
makes me think of automobile level of
that
service.
Was the whole idea.
Which is usually, ranked A through E, depending on
right.
levels of congestion. My question is, if you did any kind of similar ranking on the bike facilities, and if so, or maybe if not so, how do you see it relating to other modes level of service?
Okay, that's actually a good question. When I was doing this, I was trying to, in this modeling process, is trying to figure out which variables are significant. The next step is to take those significant variables, figure out, what was it called? I need to, excuse me while I consult this. What do they call it? It's the coefficients of the variable. Take the coefficients, how much a variable influences the overall model, and basically use those variables, weight those variables based upon the coefficients within an overall index, if you like, and then use that index within a GIS. And you could physically show it with something called 3D modeling within ArcView in the spatial analyst portion, where you could actually show areas with higher level of service and areas with lower level of service based upon those variables. And that was the whole idea of the original regression, is to figure out which variables are going to suggest higher levels of service and which ones were not going to be likely to be all that significant. And I suppose that would be the next step beyond this. But that said, I could show it what it is in Northwest Portland, but would that be relevant? Because the life cyclists are just passing through. I mean, there is sort of various logical errors in the whole area that was covered, but I think that would be logically the next step. There's a question over here, and then Bertini.
Do you see any implications for policy in your results?
I think anybody who's in planning, who does even any of stuff like this, that does enter their mind. The whole idea of putting this together was to create a GIS for analyzing it, but like any planner, I want to use the GIS sometimes as propaganda, if you like, or some way of promoting an idea that certain areas need better facilities, more facilities, and certain other areas probably have enough, really. But I think I sort of have to sometimes separate doing peer research from doing policy support, if you like, using GIS for policy support. And as far as doing peer academic research, I've tried to concentrate on that on this particular presentation. But of course, yeah, I mean, you could use this or misconstrue it any way you like. And that was the whole idea from the beginning, was to create various methods to modify the data to show academically what needs improvement, what doesn't, and then also to show from a policy point of view what could be improved, what couldn't be, or what could be improved at the least cost to the greatest benefit. Okay. I'm going to go back and then.
How long did it take to do that whole point?
That's a tricky question. In reality, it took probably about 6 months of actual work. But I've been working on this for 5 years, and obviously I've been interrupted by such things as classes. Anybody who goes through any master's program has to do that, unfortunately. And then I worked over at PDOT for 2.5 years, and it was effectively full-time. So that was a big interruption as well. But if actual, I mean, it's like one other person or a former faculty member once told me, any project you do, it's 9 months of thinking, it's 3 months of writing, or something to that ratio. So, yeah, it's fairly typical. It's a little bit more long than some. Bertini.
Beginning, you quoted the 1965 Highway Capacity Manual. Right. And the reason that traffic engineers use bicycle level of service is to kind of answer the question, do we need, for planning and design purposes,
right,
a bike facility, and if so, what kind?
Right.
What I wanted to ask, or what I wanted to mention, is that there's a national discussion going on regarding eliminating this whole concept of level of service and moving towards a more rational performance measurement system. Since we're able to actually analyze real data now, so we don't need these grade level, or some people propose we don't need these arbitrary grade levels. So have you thought about how, if you were trying to design the perfect system for determining bicycle performance and using that information for planning and design, would you come up, well, can you just say a word or two on that?
Yeah, sure. I think, well, I when I was reading the various planning documents for various cities and how they were going about doing it, specifically the most detailed ones were from King County, Washington, and then the city of Bellevue, which is in King County. they had pretty detailed summaries of how they do it. And the big problem with level of service versus tracking behavior is that pretty much only a big city or a populous county with a fair amount of money can actually do that. For a smaller city, like I was looking at Victoria, British Columbia, they really do have to do level of service. It's a lot cheaper. You're basically estimating what's going on, and you're having to use variables that you can get a hold of or that you might already have. Trying to collect data on how people actually behave. You can do it in university communities, and most communities do have some university. The reason being, students are cheap. I mean, they're an incredibly cheap labor resource that you can easily exploit, and most cities exploit them heavily. But a lot of cities don't have large universities, and a lot of smaller cities have nothing. I mean, so it's like they need to figure out various methods for analyzing bicycle usage, because they have the same problems that the bigger cities do, in that their states or the federal government requires a certain amount of bicycle or pedestrian facilities, and the city's uncertain how to do it, and oftentimes their citizens require that. And so a city with its limited resources has to figure out how to do that.
I had another traffic count idea.
Okay.
I don't know if this has come up before, but what about using remote cameras, security cameras,
Right.
PDOT cameras, and running them at fast forward so you don't have to wait?
Actually, I've seen something that Tom Jensen over at PDOT was doing. They have cameras around town for traffic, and their job is to watch these, and so they have like a fast forward thing where I watch traffic. I don't know if any of you have seen this, but it's incredibly hilarious watching traffic go by really quickly. Essentially, no, it's just watching a bus go stop, drop people off, and then zoom on. Boy, you wish the whole system operated that way. That said, one could. On the other hand, a lot of cyclists don't follow the same kind of traffic stream or predictable stream that a car does. Bicyclists tend to weave in and out a lot. In an emergency, they'll go ahead and use the sidewalk for safety reasons. So bicyclists, unfortunately, are a little bit unpredictable. But that said, that would be a cheaper way of doing it. Thanks. Okay, you're very welcome. That would be actually a good way to do it, I think, on the long run. If you had some idea ahead of time where bicyclists are likely to go, or if you're thinking of doing a change to a street that doesn't have a bike lane, will bicyclists use that? Well, you could record to see whether bicyclists are already using the street. That would be a very good way of doing it remotely. Go on.
When you say bicyclists, I'm assuming you're using adult bicyclists?
Well, okay, that was interesting. When I looked at the original literature, it basically divided the bicycle world into three kinds of bicyclists. Basically, you had your commuters, which proportionally varied city to city. You had your adult recreational cyclists, and then you had children. The problem with children is, well, first of all, they're usually very numerous in any community. Up until they're 16 in most states, they can't drive, so legally, most of them are on their bikes. I come from a state where a lot of children learn to drive when they're about 10 or 11, but still, and they're not necessarily bad drivers even at that age. That said, in most major cities, children are considered, they're going to be using bicycles. But unfortunately, they don't follow the same rules that adults do. They'll often dart out through traffic. They'll do things that I couldn't do, neither legally nor psychologically. And so they're harder to account for. A lot of cities try to provision their bicycle facilities for children and realize they just don't work. Children don't follow rules. children go where children go. So a lot of studies have switched to trying to encourage commuters and adult recreational riders. And so I had to kind of imply that in this whole study, that I'm basically not looking at children cyclists. I'm hoping they'll use facilities, but there's no way I can check that.
So do you think you could use this concept of level of service, say, in the context of safe routes to school?
Oh, I see what you mean. Yeah, you could, with the assumption that people would use the routes in a conservative manner. But, you know, when I was a kid, I certainly didn't. And most other cyclists I know did pretty stupid, crazy things when they're younger. So, I mean, that's making a huge number of assumptions if I did say that. Generally, I am aiming this more towards an adult population of cyclists.
I was wondering if during your research you ever came across any other studies similar to yours, but for pedestrians.
Oh yeah, well, Holly Hendricks from the PhD program here did something somewhat similar. I mean, she was looking, I think, more at the relationships within neighborhoods, but I think she came across a lot of literature related to that. And yeah, I mean, a lot of the modeling techniques that I looked at, there was a lot of pedestrian crossover. There's also looking at rollerblading. It's something I don't cover on my study, but I've seen similar studies looking at that, not so much skateboards. And then a little bit on moped usage, especially in the Netherlands. It's important. Mopeds are allowed on the bike lanes there, which is kind of strange.
Any last questions? Okay.
All right.
Before we thank you, I'm going to put in a plug for next week's speaker. Mike Hoagland from Metro is going to be talking about transportation finance. So those of you who have had questions about, well, how does stuff get funded in the region, he'll be able to answer those questions. Thank you very much, David.
Thank you.
Hold on.
Sorry.
Maybe we should say something about 2 weeks from now also. Andrew Wilson from the U.S. Forestry Service is going to be talking about how they develop travel time models on a transportation network similar to the ones that we use for our modeling to develop plans for forest fire response. So I wanted to put in a plug for that 2 weeks from now, and also remind the students who are enrolled with me to submit questions. I think I've received 2 so far this quarter. And now, thanks, Dave.
You're welcome.